Today we are going to start Unit 29, Naming and Physical Properties of Carbon Compounds. So in grade 10, you have already learned how to name some simple organic compounds. Okay, so here on this table, you should already be able to name alkenes, haloalkanes, and alcohols, and also carboxylic acid. So in this unit, I'm going to teach you how to name aldehydes, ketones, and also esters. So in your IFY syllabus, amines and amines are not included, so I'm not going to talk about them in this unit. But if you are interested, please go to the suggested textbook for more information. The first type of organic compound I'm going to introduce in this unit is called aldehyde. So aldehyde, it contains a functional group that the carbon is double bonded to an oxygen. And this C double bond O must be at the end of the carbon chain. Okay, so the general formula for aldehyde should be R or H attached to this functional group. So R means a carbon chain. And sometimes you may also see that aldehyde can be written as R, the alkyl group, and then C, and then HO. Okay, and remember, previous year we have learned the general formula for alcohol is ROH. Okay, so to be able to distinguish between alcohol and aldehyde, okay, for aldehyde you must write H in front of O. Okay, so how can we name aldehyde? It's very similar to the way that we name alkanes, but we just remove the E at the back and we change it to AL. Okay, so here is an example. On the left-hand side, we got the molecule which have 2 carbons as the longest chain. Okay, so we name it as ethane. And then if we attach the functional group at one of the carbon, then it changed to aldehyde. So we would just change the ending. So it will be named as ethanol. Okay, because aldehyde, the functional group must be attached to the end of the carbon chain. Okay, so there's no need to indicate the position of the functional group, just like alcohol and carboxylic acid. It's always as position 1 in the carbon chain. Okay, so here are some more examples. Okay, if the longest carbon chain got 3 carbons in it, 1, 2, 3, then we name it as propanol. Okay, here, for example, for this example, the carbon chain start from here, and the longest carbon chain got 1, 2, 3, 4 carbons in it, so it should be butanol. And also, we have one methyl group attached to the second carbon, so it should be named as 2-methyl-butanol. Okay, and for this one, we can see it got a benzene ring attached to the functional group, so we name it as benzaldehyde. Okay, so that's a special case. Let's try some examples together. Here we got 3 molecules. Okay, let's apply the rules and name it. For the first one, okay, let's work out how many carbons in the molecule. 1, 2, 3. So it got 3 carbons in total, so it should be named as propanol. Okay, let's take a look at the second example here. Okay, carbon 1 is here, and then let's find out the longest carbon chain, 2 and 3. So longest carbon chain, again with 3 carbons in it, so it should be propanol. And then we also got a methyl group which is attached to the second carbon, so it should be named as methyl propanol. Okay, so why I don't add numbers to it, why there is no 2 attached to this? Okay, because this methyl group cannot be placed at the other position. Okay, so if you add a 2, it cannot be at position 3, otherwise it will become this. Okay, so the longest carbon chain now become 1, 2, 3, 4. Okay, so it becomes butanol, okay, instead of propanol. So there's only one way to put this methyl group, so there's no need to put 2 in front of this methyl. So the name should be methyl propanol. Okay? Okay, the next example. Okay, so we label the functional group carbon as number 1, and then we got number 2, and then we got a benzene ring. Okay, so for this one, how do we name it? Okay, so for this one, we consider this benzene ring as a group attached to the longest carbon chain. Okay, so the main chain will be named as ethanol. And then we also got a benzene ring, so the benzene ring is called a phenyl group. Phenyl group. So it should be called as phenyl ethanol. Okay? Okay, then we move on to the next type, ketone. Ketone is very similar to aldehyde. Okay, the functional group also contains C double bond O. However, this time, this C double bond O must be in the middle of the carbon chain. Okay, so the general formula should be an alkyl group attached to this C double bond O, and then another alkyl group attached to it. And this functional group, we call it a carbonyl group. Okay, so again, similarly as the rules we use for aldehyde, but this time we change the ending into O-N-E, okay, ketone, O-N-E. Okay, and for this one, because the functional group is placed in the middle of the carbon chain, so it needs to be mentioned when necessary. The position of the carbonyl group needs to be mentioned when necessary. Okay, so here we got an example. The first molecule got 1, 2, 3, 4, 5 carbon in the carbon chain, so we call it pentane. Okay, if we change one of the carbon and make it double bond to oxygen, then it becomes a ketone, and the position is at the third carbon, 1, 2, 3, at the third carbon, so it's named as pentane 3-one. Okay, let's finish the checkpoint questions together. Here we got 4 examples. The first example, the longest carbon chain got 1, 2, 3 carbons in it, so it should be named as propanol. And there is only one way to put our C double bond O. Okay, it must be put in the middle of the carbon chain, so no need to mention the position of the functional group. So just name it as propanol. Let's take a look at the second example. Okay, so there are 4 carbons, 2, 3, 4 carbons in the chain, so it should be named as butanol. Okay, so for this one, do we need to mention the position of this functional group? Okay, would this functional group be able to place at position 3? Okay, we can draw the possible answer here. Okay, imagine if we move this functional group to so-called position 3, and then let's label those carbon again. Remember, your functional group, we should always try to give it with a lower number. Okay, so for this molecule, we should number our carbon from left hand side. So it will have carbon 1, carbon 2, carbon 3, carbon 4. Okay, so it's actually the same as the one that we have below here. Okay, so there is only one possible position for us to put this functional group. So there is no need to write the name as butane 2-on. Okay, that's wrong. Okay, no need to mention the position for this molecule. Take a look at example C. Okay, so the first we need to label all the carbons and find the longest chain, and at the same time we need to make sure that the functional group got the lowest number. Okay, so for this one we should label our carbon from the right hand side. So that's carbon 1, carbon 2, 3, 4, 5. So the longest chain got 5 carbons in it, and you should notice that we also have a methyl group attached to the 4th carbon. Okay, so we name the longest carbon chain first. It should be called pentane 2-on. And then remember we have the methyl group and it's at position 4, so it should be named as 4-methyl pentane 2-on. Okay, take a look at the last example. Okay, here the longest carbon chain is a bit special. Okay, it's a cycloalkane. Okay, and it got 6 carbons in it. 1, 2, 3, 4, 5, 6. 6 carbons in it. Okay, and the although I number this carbon as the 6th one, but because it's a cycloalkane, so it's actually in the middle of the carbon chain. Okay, so how do we name it? Okay, again we follow the rule but changing the ending. Okay, so it should be named as cyclohexanol. Okay, the last type of organic compound that you are going to learn is called ester. So ester contains a functional group that the carbon is double bonded to an oxygen, and also it would single bonded to another oxygen, and that's a functional group for ester. And the general formula for ester would be a group of atoms attached to the functional group, and then on the other side we got another group of atoms. So here it further explained these two R groups can be alkyl group or aryl group. So what are these? Okay, so the first type, the alkyl groups, means we remove an hydrogen from alkane and attach it to the functional group. And for aryl group, we are removing a hydrogen from a aromatic ring. Actually, we've seen an example on the previous page, which is this group. Okay, so you can draw it like this, or you can draw it like this. Okay, so for this one, for this group, we call it a phenyl group. Okay, so for an ester, R1 doesn't have to be the same as R2, okay? It can be the same, it can be different. There is no restrict on this. And how do we name ester? It's a little bit complicated, okay? That's because ester are formed when two types of molecule are joined together. So the functional group, we can actually separate it into two parts. So you can see there is a C double bond O part. This part actually comes from a carboxylic acid. Okay, so if we can work out the original carboxylic acid, and then we will be able to change the ending of that carboxylic acid and change it to O8, O-A-T-E. And then on the other side, we got this single bonded O in the molecule. This part comes from an alcohol. Okay, and if we work out the original alcohol molecule, we will change the ending into YL. And then we just need to combine these two parts. Okay, and remember to leave a space in between. Okay, it sounds a little bit confusing, but after I show you an example, it might get a bit clear. So here, you can see I have an alcohol, the ethanol, okay, and I also have a carboxylic acid, methanoic acid. Okay, so when these two type of molecules are put together, actually we can remove the water, okay, from these two molecules and form an ester. So we are going to remove one of the hydrogen from the ethanol, and then we are removing the OH group from the methanoic acid, and then it will be the esters formed on the right hand side. So on the right hand side, remember we change the name of the alcohol, and then we put it at the front. So the alcohol that we put in is ethanol, so we change the ending into YL, so it will become ethyl. Okay, that's the first part. And then with a space, and then we are going to put the name of the carboxylic acid but ends in OATE. Okay, so here we have methanoic acid, so we're just going to change the ending into methanoate. Okay, so the name of this methyl group, the name for this ester is going to be ethyl methanoate. Okay, so the name of the alcohol plus the name of the carboxylic acid, but remember to change the ending of these two original molecule. Okay, so how about the next example? Again, we are going to remove the hydrogen from the alcohol and also the hydroxide group from the acid. Then the ester that we are going to form is this one. Okay, and then single bond to O, and then that will be bond to this group in the acid. So how do we name it? Okay, so we're going to change the ending of the acid of the alcohol, okay, and put it at front. So the name for the acid part will become methyl, and then with a space, and we are going to change the name for the acid and end it in OATE, so it will become benzoate. So the name for this ester is called methyl benzoate. Okay, and it also release one water molecule. So when we write the equation in, you need to have that attached. Okay, let's complete the checkpoint questions together. Okay, so whenever you are trying to name the ester, you need to first find the original alcohol and the original carboxylic acid. Okay, so let's try the first example together. So we should break it here, and remember the right hand side is from the alcohol and the left hand side is from the carboxylic acid. Okay, and let's work out what's this alcohol. Okay, so we got 1, 2, 3 carbons in the carbon chain, so it's propanol. Okay, and then we change the ending, so it would become propyl. Okay, and then let's consider the carboxylic acid part. So we got 1 and 2 carbons, so that's ethanoic acid. And then we change the ending into OATE, so it will be ethanoate. Okay, and for the second example, again we break it into 2 parts. On the right hand side, it comes from the alcohol. So let's find out how many carbons on the longest chain. Okay, so we got 1 and 2. Okay, so the longest chain is it got 2 carbons in it, and we have a branched methyl group attached to the longest carbon chain. Okay, and on the right hand side, it comes from the carboxylic acid. Okay, only 1 carbon in it, so that's methanoic acid. Okay, so we're changing the name of this alcohol molecule. So this alcohol molecule is called methyl ethanol. Okay, so if we just change the ending, it will become methyl ethyl. And then let's attach the name for the carboxylic acid. Here only 1 carbon, so it's methanoate. Okay, then the next example here, again break it into 2 parts. Left hand side comes from the alcohol, which only got 1 carbon in it, so it will be methanol. On the right hand side, let's number the carbons. Carbon 1, 2, and 3. The longest chain got 3 carbons in it, and then we got a methyl group attached to it. Okay, so let's consider the name for the alcohol parts. So it only got 1 carbon, so it should be called as methyl. And for the carboxylic carboxylic acid part, okay, it got a branched methyl group, so it should be named as methyl. And 1, 2, 3 carbon, so it's originally it's propanoic acid, and then we change the ending, it should become propanoate. Okay, so total will be methyl propanoate. Okay, so here some of you may ask, why don't we need label the position of this methyl group? Okay, can we put it at a different position? Can we move it to this position? Okay, we can actually draw the possible way. Okay, so if we move that, okay, if we move this methyl group to so-called the position number 3, okay, so it will be 1, 2, 3, and then the longest carbon chain will become 4 carbons in it, okay, not 3 anymore. So again here, only one way of putting the methyl group, so there's no need to name it as 2-methyl propanoate. Okay, there's no need to mention the 2. Okay, let's take a look at the last example. Again, break it into 2 parts. The alcohol part only got 1 carbon in it, so it would be methyl. And then for the carboxylic acid part, okay, we have just come across this example. Okay, so we just consider it got 2 carbons in it, 1, 2, and then a phenyl group attached to it, So for this carboxylic acid, we would name it as phenyl ethanoic acid. If we change the ending, then it would become phenyl ethanoate. Okay, so that's how you name this molecule.